Clear? Copied? Yes, you can write this question. The ADF of an aircraft on heading of 189 degrees true will experience the greatest effect due to quadrantal error if the NDB bears. So I'll give you some time. Alright, so here, what is the heading of the aircraft? 189 degrees true. So it's okay, you're in line with the options, so no variation, no conversions required. Right? You should be able to think in a broader platform, because only if you have the thought process coming into it, that in case of a conversion required, that will trigger it. Otherwise, you probably will forget it. So always think that, okay, I have the heading in true, and therefore the options are in true, so the conversion is not required. But if the options are in magnetic, you probably have to use the variation, which is converting true from magnetic. Alright, perfect. So heading of the aircraft is 189 degrees true. You see the aircraft will have the longitudinal axis and the lateral axis. The direction in which the nose or the longitudinal axis of the aircraft is pointing with respect to true north, because it's true here, that is what is called as the heading, and which is 189 degrees. Now, you don't have to necessarily draw it in the actual orientation using the true direction system. You can draw an aircraft in whichever convenient positions you want. What I mean by saying that is, if I want, I can draw the aircraft like this and still represent this as a heading of 189. That's still fine. You don't necessarily have to draw the aircraft like this for it to be 189. I would always prefer this because it gives me a better orientation. For these questions, it is not required. Don't confuse yourself by drawing this one. Yes, now this is the longitudinal axis of the aircraft, just in case if you want to draw that. This is the lateral axis of the aircraft. Now, what's the next thing? You're asked to find out where is the quadrantal error maximum. In that case, where is the NDB? The NDB bears a track of so much. That's exactly what is given. This is basically the QDM that is given the question. That's why it says the NDB bears. It is always a track till the station, right? Let's find out. Let's look at the different quadrants here. Over here, this is let's look at the relative bearing. The relative bearings are at 45 degrees, 135 degree, 225 degree, and 315 degrees. Right? You have to say this with me. There's no point in me saying the whole thing. So when I'm saying, I want you to talk with me, right? Yes. So So what are the different? These are the relative bearings. If it is the relative bearing that is asked in the question, you have to pick up one of these, and that is completely independent of your heading. Say for example, in this particular option, if you look at 2 to 5, you have 2 to 5 here, and what is that? That is basically the relative bearing where you will have max quadrantal error. But that is not what is asked in the question. You're asked to find out the QDM. The NDB has to bear one of these bearings. And for that, let's find out the different QDMs here. To find QDM, add your heading with relative bearing. What is it? 189 plus 45?
It is 234.
234 degrees. True. What about this? The QDM? Yeah.
Plus 90, 324.
324?
324 degrees true.
Okay.
Then it comes 054 degrees true.
054 degrees. So adding the heading with the relative bearing, or just keep adding 90.
Yeah. Or then it is 144 degrees true. 144
degrees true. At these QDMs, you will have maximum quadrantal errors. Now you see 144 degrees true, 234, 324, 054. So pick up the option where you will have maximum quadrantal error, and that is 234 degrees true. Now look at this option here, 145, and look at the option here. So be careful.
Okay.
Since you have 234, I would always go with 234. If I did not have 234, I would probably go for 145 because it's at least closer to 145. Makes sense? But since I have the exact value here, that's the most appropriate answer, right? Let's find out whether this value has any significance here. 279. So let's find out the bearings where the quadrantal error would be minimum or almost 0. So that is going to happen along the longitudinal and the lateral axis, right? So you can see this 189, and therefore what is going to be this one? It's 189 plus 180, therefore it is going to be 269 degrees. Sorry.
No, minus 009.
0009 degrees, right? What about this one? This 189 plus 90, which is 279.
279.
By 099. And these QDMs, you'll have minimum quadrant error. So look at the option here, we have 279. So what does that correspond to?
Minimum
Quadrant error. Right, so you can see all these things here in the option. So be very careful. If you go wrong, chances are very high that you might find your answer in one of the options, and it's very easy to go wrong. Right, so make sure you get the answer right.